ஆரம்பிக்குது. Hello, I have sent a link to you. That is YouTube link. You just join in the YouTube. My app is not working, so that is a YouTube live actually. You just click and join in that.
Sir, I'm joining, sir.
Okay, okay.
Yes, sir.
If there is any problem, let me know. So that.
Okay, sir. Okay, sir.
Hello? Hello?
Can you hear me, sir?
Have you joined?
Joined, sir. Yes, sir.
Can you see the screen?
1 second, sir. Yes, sir. But I can see the screen, sir.
Yes. White background.
Yes, sir.
Yes. You will start.
Okay.
So the topic is carbonyl compound. And in that, oxidation of aldehydes and ketones. If you take an aldehyde like this, CH3C double bond OH, the compound's name is acetaldehyde. When the acetaldehyde is oxidized by using the common oxidizing agents, either we can use acidified potassium dichromate K2Cr2O7, or we can use alkaline potassium permanganate or chromic oxide. By using one of these oxidizing agents, an oxygen can be incorporated into that. so that it can be changed into a carboxylic acid like this. The carboxylic acid formed here is called acetic acid and also called as ethanoic acid. The compound's name is ethanoic acid. And in the same way, if you take any one of the aldehyde, including the formaldehyde, propionaldehyde, aldehyde, they can give the corresponding carboxylic acids. But what about the ketones? When the ketones are oxidized, we know that we can take CH3C double bond OCH3. This is a ketone and its name is acetone. When the oxidation of this ketone, the bond can be ruptured like this. Due to that breaking up of bond, we can have a product like this ethanoic acid, and this part can be changed into carbon dioxide and water. Just see the product. It has got only 2 carbon, but we were started with 3 carbon. So the ketones are giving the carboxylic acid with lesser number of carbon atoms. That's the difference in between these two, aldehyde and then ketone. Aldehydes are giving carboxylic acids with same number of carbon atoms, but ketones are giving carboxylic acids with lesser number of carbon atoms. 2 carbons are present due to the breakup of bond or due to the cleavage of carbon-carbon bond while the oxidation of any ketone. So here the acetone is best example of symmetric ketone. Suppose if you take an asymmetric ketone, what is this asymmetric ketone? The asymmetric ketone, I can write, it's a compound CH3, CH2, CH2, C double bond O CH3. It is to follow this oxidation should be governed by a rule called as Poffert's rule. So based on that, what's happening? Here there are 2 types of cleavages. If one will be the A-type cleavage. We can have a A-type cleavage. According to that A-type cleavage, the alkyl group having lesser number of carbon atom is leaving with the carbonyl group. Just see this splitting. This CH3 will take up the C double bond O. So due to that, we can have a product number 1, CH3 C double bond O, OH. And other one, this system contains 3 carbon atoms. So that on oxidation, we can have a product like this. This acid is called as ethanoic acid. This is the acid called as propanoic acid. So these 2 are the products when the cleavage is A-type. In addition to that, we can have one more type of product. The other type of product or other pattern would be B-type cleavage. See the B-type cleavage. Now the C double bond O is moving along with the higher alkyl group. So due to that, we can have the product number 1, CH3, CH2, CH2, COOH. And other will be HCOOH. This system contains 4 carbon atoms, so this is to be called as butanoic acid. And in other side, the carbon can have only 1, or the compound is having only 1 carbon atom, so that you can call it as methanoic acid. According to the suggestions of Poffer, according to the idea given by this rule, always the alkyl group, the lower alkyl group should leave along with the C double bond O. So this should be A type cleavage can give a major type of product. So these are the major products possible and these are the minor products possible. I repeat, it's a ketone. Its name will be pentanone. Yes, you see, there are 5 carbon atoms present in the lineage chain 1, 2, 3, 4, 5. So that you can call it as pentanone, particularly 2-pentanone, asymmetric ketone, because on both sides of the C double bond O, the alkyl attachments are not same. According to the Parfit suggestion, the C double bond O is leaving along with the CH3. So the cleavage is A-type cleavage. CH3 C double bond O part can give ethanoic acid. And the CH3 CH2 CH2 part can give propanoic acid. In simple words, whenever the cleavage of unsymmetric or asymmetric ketone is considered, the lower alkyl group should be removed along with the C double bond O. Carbonyl group is leaving along with the lower alkyl group, and a higher alkyl group will not leave along with the C double bond group, and hence A-type cleavage can give major type of product, and other one B-type cleavage can give minor product. So you must take utmost care while writing the reduction reaction according to this. And ordinarily, when the ketones are reduced, the next reaction after oxidation, we can discuss about reduction reaction. Reduction of aldehydes and ketones. Yes, we can mention this aldehyde CH3 C double bond O H. The aldehyde's name is acetaldehyde. When this acetaldehyde is treated with the lithium aluminum hydride, that's a reducing agent. It can provide, the hydride can provide H minus ion. It can behave like a nucleophile, the H minus. It is going to attack this carbon, and the H plus may get this pi electron. So attack of nucleophile followed by the protonation, because it is to be supplied with 2 hydrogen, so that the product would be CH3 CHHOH. Corresponding alcohol is formed. The alcohol formed is ethyl alcohol, ethanol, primary type alcohol is formed. So whenever the aldehydes are reduced by using the lithium aluminum hydride or sodium borohydride, this should be the result. It is changed into CH2OH. So this part can be highlighted so that you can have a better idea. This, you just see the C double bond OH present in the aldehyde is getting converted into CH2OH. During this reduction reaction with the help of lithium aluminum hydride, that provides H minus, so nucleophile is added followed with the protonation. That leads to the formation of primary type alcohol. Suppose if you take a ketone instead of aldehyde, so then what happens when the ketone is reduced by the same type of reducing agent? Yes, we can write that action now. The ketone acetone we can take having the following formula. It's a formula for the acetone. CH3 C double bond O CH3. On reduction by using lithium aluminum hydride or by using sodium borohydride, 2 hydrogens are used, newly formed hydrogens. They can be added in between the double bond. So the double bond is changed into single bond. And the product is this one, HCH3OH. The compound's name is 2-propanol, also called as isopropyl alcohol. This alcohol is nothing but secondary alcohol. Secondary alcohol is formed. And this is the reaction of aldehydes and ketones with the reducing agent like lithium aluminum hydride, sodium borohydride, even the alternating substances like platinum hydrogen, palladium hydrogen, nickel hydrogen. Any one of the reducing agent can be used up in this particular action. All are reducing agents. So that we can have one more pattern, how to convert aldehydes and ketones into corresponding hydrocarbons. You see, CH3, CH4 means that can be changed into CH3, CH3. So CH4 is becoming CH3. Hydrocarbons are made. It is possible by a named reaction called Clomunson reduction reaction. The first reaction is Clomunson reduction reaction. During the Clomunson reduction, what is going to happen? If we can start with the ketone like aldehyde or ketone. I have taken this aldehyde. The name of this aldehyde is acetaldehyde. When the acetaldehyde is reduced by using 4 times hydrogen with the help of zinc, amalgam, and concentrated HCl, what is going to happen here? For our understanding purpose, we can take like this. Okay. The stage 1 in which when you add H and then H, it becomes CHOH. On further addition of 2 hydrogens, this part is leaving. Try to see this part. It is left from the compound as a water. These 2 hydrogens are bonded there. So it becomes CH3CH3 plus H2O. The hydrocarbon mode is called as ethane. The best method to convert carbonyl into CH2 is by using zinc, amalgam, and concentrated HCl. They are the reagents used in the case of Clomunson reduction reaction. And this reaction is called as Clomunson reduction reaction. And if you take a ketone, yes, I'll be writing this ketone, CH3, double bond O, CH3. The ketone's name is acetone. This acetone on treatment with the same zinc, amalgam, and concentrated HCl. We can use 4 hydrogens. 2 of the hydrogen atoms are responsible for the removal of this water, and 2 more hydrogens can be added there. So it becomes CH3, CH2, CH3. It is for easy understanding purpose. The compound's name is hydrocarbon normal propane with the loss of water. It is very easy to understand this particular conversion. The ketone group is changed into hydrocarbon part by the usage of 4 hydrogen atoms. 2 of them are responsible for the formation of water, and 2 things can be added with the carbon. So as a result of that, we can have a product like this, CH3, CH2, CH3. Hydrocarbon, namely the normal propane is formed. And one more pattern of action, the other reaction which is given here is Wolff-Kissner reduction reaction. Wolff-Kissner reduction reaction. It is the Wolff-Kissner reduction. Take acetaldehyde or acetone by using 4 times hydrogen. The hydrazine NH2 NH2 C2H5ONA. The first part, the mechanism is not necessary. Even then you just know the hydrazine can be written as follows NH2. So attack of nucleophile followed by the protonation. You can have a compound CH3CH and it becomes OH. Here I can write NH2. Subsequently, this water is removed from the molecule so that we can have CH3CH double bond NH2. It is nothing but hydrazone. Hydrazone is one. In the very next stage, this hydrazone on action with the base, it can be reduced like this. Yes, we can use the same 4 hydrogen atom so that the product is CH3CH3. And this can be recovered, which is to be recovered here. The hydrazine can be recovered. And that part can give hydrazine on decomposition. You will be getting the product called nitrogen. And one other product is water. H2O is removed. And this part is leaving as nitrogen. And when you add these 2 hydrogen, it becomes CH3 single bond CH3. The hydrocarbon is formed. The hydrocarbon's name is ethane. Okay. And other one, take a ketone, CH3, C double bond O, CH3. The ketone's name is acetone. This acetone on reduction by using the same hydrazine NH2, NH2 and a base called C2H5ONA, sodium ethoxide. 2 of the hydrogens are responsible for the removal of water and 2 hydrogens can be added. The intermediate is already explained to you. The mechanism is not expected here. So this is the product mode. The main compound, normal propane is mode. N-propane is the product. And it is also a most important named reaction. One is Clomunson reduction, other one is Wolff-Kissner reduction. In the Clomunson reduction, the reagent used is zinc amalgam and concentrated HCl. And in the Wolff-Kissner reduction, the reagent used is hydrazine and sodium ethoxide. That's all. The other reaction, reduction to phenol. What is called phenol and how that is made? The phenol type reduction takes place as follows. Yes, we can have a reduction pattern called phenol. Take a first molecule of acetone, CH3C, CH3, double bond O, and second molecule, CH3, CH3, double bond O. The reaction takes place in presence of magnesium amalgam and water H2O. So the stage 1 in which when you supply the hydrogen, the pair of electron is available for this. And so there is a bond formation in between these two. And actually we know the valency of carbon is 4. So when it is protonated, when the hydrogen is added with this, there will be initiation of bond in between these two. And simultaneously, one more change is possible. Just see the other hydrogen which can be added here. Protonation takes place. The 5 electrons are given to this. So definitely, there will be a new bond in between the carbon and carbon. As the valency of carbon is equal to 4, a new bond is initiated and both the double bond O's are converted into OH. So the product will be CH3, CH3, single bond C, CH3, CH3. It is changed into OH and then OH. How do you give the IUPAC name of this particular compound? The compound's IUPAC name can be given as follows. You can take CH3, 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 CH3. It is OH. The number of carbon atoms in the longest linear chain. How many carbon atoms are present in the longest linear chain? That you should find. 1, 2, 3, 4 carbons. As there are 4 carbon atoms in the linear chain, you can call it as butane, in which the carbon 2 and 3 are having the alcoholic group, so 2, 3 diol. And the branches are found at 2 and 3. The name of the branch will be the methyl. There are 2 methyl groups. Thus it is 2,3-dimethyl butane, 2,3-diol. This substance is said to be the phenol. Phenol is merged with this. Here the phenol arrangement is possible as follows with the help of 2 molecules of acetone. Yes, this is the phenol formation. Just I am repeating it. CH3C, CH3, double bond O plus C, CH3, double bond O. The reaction takes place in presence of magnesium amalgam and water. When there is an initiation of bond in between them, you can add 2 hydrogens like this in the simplest way, so that the product is given as follows. It could be the product, in which totally there are 4 carbon atoms in the linear chain. So the source substance is butane. 2 and 3 are having the alcoholic function, so it is 2,3-diol. The branches are found at 2 and 3. The branch is nothing but methyl. So we can have 2,3-dimethyl butane, 2,3-diol. This is the substance called as phenol.